Hi there, and welcome back to my channel. In this video, I'm going to take you through tri-diagonal systems. So, in our previous lessons, we've gone through the different methods for solving systems of equations, the Gaussian, which is the naive and the partial, as well as the complete pivoting. So, we continue from the tri-diagonal systems. So, what we say when we say tri-diagonal systems, what are they? So, as the name suggests, tri, right? So, three. So three diagonals. If you have any system represented in a matrix form and having the entries lying on what three diagonals, then we say that it is a tri-diagonal system, right? So for diagonal matrix, you know that a diagonal, we have the principal diagonal, which is exactly the center for every n by n matrix, right? Then above the principal diagonal, we have the second diagonal here, and we have below. So every tri-diagonal system satisfies this matrix form. It has the principal diagonal as well as what the diagonal after and before the principal diagonal. Now, what's the usefulness of tri-diagonal systems? So whenever you are solving a system of equation and it satisfies or the matrix form represents a tri-diagonal system, then we have a simpler way for expressing it in what? In the triangular form. Okay. And you know that the goal of expressing a matrix in the triangular form is to solve our systems of equation easily, right? Using either backward or forward substitution. So in this video, I want to show you the simple way to decompose a tri-diagonal matrix system into what? LU form. Okay. So I have a trigonal matrix here to illustrate to you. So if you want to decompose this tri-diagonal system into the LU form, and you know that L stands for what? The lower triangular matrix, while this stands for upper triangular matrix. So lower triangular matrix, right? Triangular matrix. And the U stands for upper triangular matrix. Upper triangular matrix, right? So to triangularize tri-diagonal matrix systems, you just have to follow some simple procedure, which is quite different from the normal systems you know, right? So here you can clearly see that the entries of our matrix are on the principal diagonal. I have A, so A1, A2, depending on the size of the matrix, up to AN, right? Then above the principal diagonal of our matrix, I have B1 to Bn minus 1, which is rightly above our AN. Then I have C, which is below, right? So with this configuration, if you want to decompose into the L form, how do you do that? The L form becomes a unit lower triangular matrix, a unit. Unit because the entries on the principal diagonal will be 1, right? And right below it will be what? Our entries for L, that is the lower portion. So we will have L, L2, L3. I mean, you have entries of L on this particular diagonal, whilst above the principal diagonal everything turns 0, and also right behind this L everything turns 0. So when you decompose a tri-diagonal system, you're going to get a bi-diagonal system multiplying another bi-diagonal system. Okay, so we are expecting only two diagonals in our matrix after decomposition. Likewise, for the upper triangular matrix, on the principal diagonal, you're going to have elements of your upper triangular matrix. So it's strictly upper triangular matrix. And above it is also what? The B. And you realize that this B is the direct entries of what? Our system. So to decompose a tri-diagonal system is very, very simple. This is because the entries here will be repeated as part of the upper triangular matrix. So the only thing to look out for is your what? L component and your U component. Then you are good to go. So if you want to use this to solve a system of equation, as usual, as we've been doing in our previous videos, as this one represents L, this represents U, to find the values of unknown, let's say x1, x2, let's say x3. To do that, the LU algorithm says that you always find L times any unknown, let's say y, is equal to the b, and also your u times what the x, which are the unknowns, is equal to what this y. So this becomes the algorithm for finding what solutions to unknowns given any system where you use the LU decomposition, and that is what we are applying here, because this is a tridiagonal system and you have been able to decompose it into L and U form. So I just carry the L and multiply by an unknown matrix, equate it to my B. Then whatever I get for Y, I'll equate that to what UX, and I'm good to go. I have a problem here to solve with you. So how we can triangularize a tridiagonal matrix into LU form. So the problem is triangularize A, which is a tri-diagonal matrix using the formula A equals LU, right? So when I triangularize this, I'm supposed to get two triangular components, the upper and what the lower, right? Yeah. So why is it diagonal? So you can clearly see that I have my first diagonal, my principal diagonal, as well as what this diagonal. So it's three. That's what you call what a tri-diagonal system, and I have zeros at the end. So this process I'm going to take you through works for only this system, Okay, so let's see how we are going to triangularize this matrix using the LU form, right? So I simply write my matrix here, my matrix A. So my matrix A, I have 0 0.9, I have 0 0.5, I have 0 0.5, right? And I have my second diagonal 0 0.8, 0 0.8. Let me write over. So I have 0 0.8 here, and I also have 0 0.1 here, and I have here to be 0, 0 0.1, 0, 0 0.1. So if I do this decomposition, I should get the L form. So now let's see from here. Our L form has on the principal diagonal all ones, okay? So if you want to write the L form, always put all ones on the principal diagonal. So let's see how we do that. So I'll simply put all one. This is a 3 by 3 matrix. So 1, 1, 1, right? Then once you do this, for every lower triangular matrix, after writing your principal diagonal, whatever comes above it becomes what? Or the right side of it is all zeros. So I have 1, 0, 1, 0. This side will have 0 here. Then you just have to wait for what? The entries here, right? So this is the L form. So now let's see. As I said, you should have two diagonals in each section. So here, let me report the L part, okay? So let me make here, let's say, L1, then here will be 0, right? Then here will be, let's say, L2. Now let me find the U. So from the U2, how do you do it? We have on the principal diagonal what? The U times, okay? Then above it is what? The B, where the B is exactly the element in the main matrix given, right? So it's just a direct something. And whatever is below or at the left side of our principal diagonal is all zeros. So let's see how we do that. So I'll simply have my U1, U2, U3 as elements on the principal diagonal, right? Then right here is what? My what elements here. So I'll just take these elements and I'll write them. I'll have what 0 0.1 here, then I'll have what 0. Then this side becomes what 0 0.1, right? Then right down here, everything turns 0. So I have 0, 0, and I have 0. So now I have been able to decompose this into the LU form, but I still have some unknowns. So the next thing to do is to remove all the unknowns and replace it with the corresponding values, okay? So to do this, this is a simple matrix equation. I need to find L1. I need to find L2. Likewise of U1, U2, U3, right? Yeah. So what do I do? When I multiply this row, okay, when I multiply this row by this column, I'm supposed to get what? 0 0.9, right? Likewise, when I multiply this by the second column, I'm supposed to get 0 0.1 in that manner. So I'm going to use this multiplication of matrix approach for us to what? solve for the unknowns here. So starting with the first row, multiplying the first column here, I'll get what u1, right? So I get u1 is equal to, so it's u1 times 1, everything becomes 0. So u1 times 1 is u1 is equal to what? 0.9, right? I simply write 0.9. So u1 is what? 0.9, right? So now this same column, when I multiply it by the second row, there wouldn't be any unknown I'm looking for, right? Because the unknown here will be what? Multiply by the 0 to be 0. So the next thing to do is you just come straight towards our second row, right? You just come straight to our second row. So for our second row, when you multiply it by the first column here, what am I getting? I'm getting L1 multiplying U1, right? 1 times 0, so it becomes 0. 0 times 0 becomes 0. Should be equal to what? 0.8, right? So right now I know that my U1 is 0.9. So therefore, my L1 is equal to, so my L1 is equal to 0.8 divided by 0.9, which is the same as 8 over what? 9, right? Yeah. So once I have this, what do I need again? I have U1 and what? L1, right? So I'm looking for L2, U2, and U3. Okay. So to find L2, I have to multiply what? This same row by what? By my second what? Column, right? So for my second column, I'll have L1 multiplying 0.1, right? Plus U2, right? Plus 0 should give us what? 0.5, which is the middle one here. So right now I know L1, 8 out of 9 plus U2 should give me 0.5, right? Should give me 0.5. So this is the same as 0.8889, right? Then when I have this expression, 8 out of 9, right, times 0.1. So let me do this here. So this is 0.1, right? So 8 out of 9 multiplying 0.1 plus U2 is equal to 0.5. Is that not it? Yep. So I will simply have my U2 to be equal to, my U2 to be equal to 0.5 minus 8 out of 9 multiplying 0.1. And what am I getting for this? So here my U2 simply becomes 0.4111, right? So I'm now having what? U1, I'm having L1, right? Then I'm having what? U2. So let me write L1 here is equal to 0.8889. So that is my entry. So what am I left with? So right now, if I multiply this row by the last column, I don't know, I can't find U3 because this is 0. So we don't do that multiplication, it's of no use. Then we come to the last row. So for the last row, I have here to be U2. I can't multiply U2 by the first column because it will be 0. So I'll simply multiply what? L2 here, L2 this last row by the second column because the L2 is in the middle. So you should be able to multiply a corresponding what? Non-zero term here. So I'll simply get 0 by 0.1 plus L2 multiplying U2, right? Plus 0 because plus 1 times 0 should give us what? If I'm multiplying the last row by what? The middle column should give us 0.1. So here this 0. This is also 0. So I'll get L2 U2 equals 0.1. So my L2 is simply equal to 0.1 over U2. And what am I getting? So I'm getting 0.1 over 0.41, right? So 0.1 over 0.41 is giving me 0.2432. Okay. So right now I have L2. So let me write L2 here is also equal to 0.2432, right? So I have this value there. Then finally, what do? I need U3, and I know that the last thing here is non-zero, so I should multiply this by what? My last column, right? So multiplying it by my last column, you know that 0 times 0 will be 0, L2 multiplying 0.1. So I have L2 multiplying 0.1, right? Then finally plus 1 by U3 plus 1 multiplying U3 should give me what? The last element, 0.5. So doing this simplification, I'm supposed to get L2. I know L2 to be what? 0.2432, right? So 0.2432 multiplying 0.1 plus U3 is equal to 0.5. So U3 is simply equal to 0.5 minus 0.024. You can add a 32 to it, okay? So the final expression is 0.4757, okay? So right now I'm having U3 to be equal to 0.4757. Yeah. So the next thing to do is I'm now done with all my unknowns. So I simply go and do my substitution and I am good to go. I do my substitution, I'm good to go. So I can come back to my matrix, then clear off all the unknowns. Yeah. So starting with the L, I know that L1 is what? 0.889, right? So I can simply write it by replacing it here. So let me clear it off. L1 is no more. So I simply write my 0.889, something like this. Now my L2, I'll clean my L2, and I know my L2 is what? 0.2432. So 0.2432. Let me clean and write everything off. So 0.2432. Then here's 1. So this is for the L, as simple as that. Then when I come to the U part, I'll simply have to take this off. So for the U part, what is my U1? I know U1 to be equal to what? U1 0.9, right? So I simply clear my U1 and I replace it with 0.9. So U1 is 0.9. Then I'm going to have, I have U2 to be 0.4111, right? So let's see how I'm telling. So 0.9. Then U2, I'll clear U2. So let me clear U3 as well. Okay. So my U2 will simply be what? 0.4111. Then my U3 is simply what you got at last, which is 0.4757. So 0.4757. So this is how we decompose a tridiagonal matrix. It's very simple. You just write your all ones and you find your L1 and L2. You write your U1, U2, U3, then you just replace this second diagonal with what? The second diagonal of our original matrix. Then you are just to find U1, U2, U3. So thank you for being with me in this video. Please don't forget to like, subscribe, and share if you found it useful.